In this video, we will look at some of the elements that make up a basic audio system, the next step being amplifiers. Similar to loudspeakers, there are a variety of amplifiers that can be used across multiple markets. An amplifier, simply put, is an electronic device that boosts an electrical current. For our purposes, an amplifier works in combination with speakers to make sound louder. They consist of three primary blocks: an input stage, an output stage, and a power supply. The input stage, or preamp, allows us to take the signal, be it from a mixing console, digital signal processor, or some other line-level source device, and boost it up to a minimum input level that the output stage can handle. The output stage, or main amplifier, can then provide the power amplification needed to drive the loudspeakers. Working in parallel to the input and output stage is the power supply. Its purpose is to process and condition power from the AC mains and deliver it to the output stage. Over the last 100 years, amplifiers have evolved from being very large, heavy devices producing a great amount of heat to smaller, lighter devices cutting down on thermal heat and providing a faithful reproduction of its input signal. These evolutions have been seen through the different classes of amplifiers. There are multiple classes of amplifiers such as A, B, C, D, F, G, I, and many other deviations. Each class has its place in today's world, offering different sonic characteristics and power efficiency that will be attractive for a myriad of reasons, whether it's the guitar player looking for that perfect tone, an audiophile that enjoys music loud and clear, or for those who are looking for an energy-efficient and great-sounding solution for a corporate installation. We won't use this discussion to get into the fine details of each amplifier class and how they work, but I do want you to have a basic understanding of their differences. Each class falls into one of two power supply technologies, either linear or switch mode power supplies, also known as pulse width modulation power supplies. Classes such as A, B, G, and H fall into the linear category, which is a mature technology offering good fidelity but are heavy, thermally inefficient, and offer poor protection to not only the amp itself but also the speakers they power. Classes D and I fall into the SMPS PWM category. These classes resolve the thermal and protection issues found with the linear power supplies while cutting down on size and weight, making it easier to fit multiple channels into a small form factor. And Class I amplifiers deliver excellent fidelity. Crown's focus is on the latter of the two power supply technologies, and many of their amplifiers today offer what is called drive core technology. Building on the Class I technology, DriveCore's front-end drive circuits leverage the inherent efficiency of Class D output stages while also maintaining superb sonic characteristics. The end result is an ultra-efficient, one-piece audio amplifier circuit that exhibits the exemplary audio quality of a highly evolved Class AB design. This new amplifier technology seamlessly integrates the amplifier drive stage into the power output stage, fusing everything into a chip the size of a dime. Okay, so now that we have a basic understanding of amplifier technologies and those at which Crown uses, we need to determine how to match an amplifier to the speakers we'll be using in our design. Let's first look at some general guidelines. Amplifier's power level should be higher than the loudspeaker program power rating if full output is needed. It's recommended you have 3 dB of headroom as a minimum. The 3 dB allows for peaks in the program material. Loudspeakers are damaged by clipping amplifiers more often than they are from overpowering. This might seem contrary, but think of it like a car. If a car has power to go only 60 miles per hour, everything is fine as long as you stay under that. But what if you need to accelerate quickly up to 70 in order to pass a truck, and you don't have enough power? Then it can hurt the engine. Loudspeakers are the same way. You need the headroom to take the peaks that can come from music and speech. What's headroom? Headroom is the difference between the loudspeaker peak rating and the maximum output. Are you wondering what clipping is? A clipped signal, regardless of where it happens, such as in an amplifier, processor, or mixer, is a DC signal at the limits of the device. A DC signal through a sound system will cause a loudspeaker to move completely to its limit. Speakers are not designed for DC signals. When a loudspeaker is at its limit, it's actually dissipating power as heat. Do you know what happens if a speaker creates enough heat? It can catch on fire. So in terms of wattage, how big of an amp do we need? As we already stated, we need to select an amplifier that is approximately twice the continuous power rating of a speaker. This will provide the necessary 3 dB of headroom. Let's look at this in terms of one loudspeaker with a continuous power rating of 300 watts. If full power is needed, we'll multiply by 2 to find we need 600 watts, allowing for 3 dB of headroom. How does this apply to our 70-volt training room application? It's fairly easy to calculate. Well, let's remember that the 8128s and the 8138s have a maximum tap setting of 6 watts and can go as low as 0.75 watts. While DSD did recommend a 0.75 watt tap setting, I'm going to calculate as though we are using each speaker at 6 watts. The reason for this is to account for the what-if scenarios where we have to use a higher tap setting on one or all the speakers. It is better to have more than enough power than not enough, considering a smaller amp will distort. Alright, so we have 20 speakers at 6 watts each. We need to sum all of these together. I'll just take a shortcut and multiply 20 by 6 and find we have a total of 120 watts. For those of you going out to buy a 120 watt amplifier, stop! We still need to account for the headroom. Now let's calculate for 3 dB of headroom. 120 multiplied by 2 gives us 240 watts. We need an amplifier capable of delivering at least 240 watts in a 70-volt system. If you look through the installed amplifiers on Crown's website, you'll find we have many amplifiers that qualify for this application. Take for example the new CDI DriveCore series amplifiers. I've chosen this particular series because of a few reasons, but the main two are because the smallest model can deliver up to 300 watts per channel, and it has built-in step-up transformers that will work in a 70-volt system. Its other features include 2 and 4 channel models, each with a BlueLink equivalent. They can be used with high impedance or low impedance loudspeakers. No additional step-up transformers are needed. Networking and control are included with each model. They are configurable using just the front panel or Audio Architect software. And they have built-in digital signal processing, allowing you to optimize your loudspeakers.